Welcome to this tutorial on using np.vectorize. In this video, you'll learn how to vectorize custom Python functions using NumPy's vectorize function. This is a powerful technique that allows you to apply your own functions to entire arrays efficiently. np.vectorize is a NumPy function that converts a scalar Python function into a vectorized function. What does this mean? A scalar function is one that works on single values, like adding two numbers. When you vectorize it, the function can now operate on entire arrays element by element without you having to write explicit loops. The basic syntax is straightforward. First, you import NumPy as np, then you create a vectorized version of your function by calling np.vectorize and passing your function as an argument. This returns a new vectorized function that you can use on arrays. Finally, you call the vectorized function with your array as input, and it returns the result. Let's see a simple example. We define a function called square that takes a value x and returns x raised to the power of 2. We create an array with values 1, 2, 3, 4, and 5. Then we vectorize the square function by passing it to np.vectorize. When we call the vectorized square function with our array, it applies the square function to each element. The output is an array containing 1, 4, 9, 16, and 25, which are the squares of the input values. You can specify the output type using the otypes parameter. In this example, we define a function called isEven that checks if a number is even by using the modulo operator. We create an array with values 1 through 5. When vectorizing the function, we pass otypes equals a list containing bool to specify that the output should be Boolean. The result is an array of Boolean values, false, true, false, true, false, corresponding to whether each number is even. np.vectorize also works with functions that take multiple arguments. Here we define a power function that takes a base and an exponent and returns base raised to the power of exponent. We create two arrays. Bases contains 2, 3, and 4, while exponents contains 3, 2, and 2. After vectorizing the power function, we call it with both arrays. The function operates element-wise on corresponding pairs, giving us 8, 9, and 16 as the result. There are some important considerations when using np.vectorize. First, it's not optimized for performance because it uses Python loops internally under the hood. Second, it's best suited for convenience when native NumPy functions don't exist for your specific use case. Third, for performance-critical code, you should always prefer native NumPy operations instead of vectorize, as they are implemented in C and are much faster. Let's recap the key takeaways. np.vectorize converts scalar functions to work on arrays automatically. It has a simple syntax and supports the otypes parameter for controlling output types. However, remember to use it primarily for convenience, not performance. When speed matters, stick to native NumPy operations. Thanks for watching, and happy coding.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.